Hello and welcome. In this video we will see briefly what is a stack and then we will do the implementation in Python. A stack is a structure to hold data and it works on the basis of last in, first out. So what this means, last in, first out. Imagine that you have a bucket like this and these will implement two operations. The first one is the push operation where you insert elements and the last element stays on the top, and then you have a pop operation where you get the last element from the stack. I also will include a display action to show the elements of the stack, okay? And the structure also will have a property called size, is the size of the stack. For example, we'll have at maximum of 10 elements, okay? Is for that purpose. Another concept in Python, you will not see this. The way of Python is using lists. You don't need a second property called count because you can get the count from the size of the list, right? But in other languages this property is very common because they just have, for example, arrays or something like that, okay? And this property, as you can imagine, is used to know how many elements are on our stack. So let's do the implementation, and the first thing to do is the stack class. Here in the code we say class stack, then we have to declare a constructor, def underscore underscore init underscore underscore, and it will receive the self and a size, the size of the stack. Then we say that we have a self.stack and it is equals to an empty list. And after this we say that the self size is equals to size that we received as a parameter, is just this. This is done, and the next step is adding a push action, a push function, okay? Back again to the code, we just have to declare a def push and it will receive self and an item, the item that we want to push into our stack. Then we check if len of self.stack is equals to self.size. We have to say to the user stack is full, okay? Remember that I said about the counter is this situation. In the case of Python we don't need the counter because we have the len of the list, okay? After this else statement we say that the self.stack append item. So if the stack is full, if as the maximum size, we say to the user the stack is full, else we add the item to our stack, to our list. Now it's time to do a pop action, okay? We just have to declare a def pop and it will receive the self. And since it will return something, we declare a result and we initialize with the number -1 and return the result. In the middle we will see if the self stack is empty. We say to the user, to the end user, that the stack is empty. Else we just say that the result is equals to self dot stack dot pop. So with this operation we are removing the element from the list and returning to the user that called this function, okay? The pop is done and the last function is the display function to display the stack to the end user, okay? So here we just have to say def display and receives the self again, and if the self stack is empty we say to the user again that the stack is empty. Else first say that we are printing the stack data, so stack data, and then we do a for item in reversed self stack, we print the item. Okay, the display function is just this. Now it's time to do the test. Okay, let me show you the code for testing this. First, I declare a variable that is false, and then I have a stack that have 3 elements at maximum. Okay, then we enter on a while, and while not exit, we display to the user, choose an operation, 1 push, 2 pop, 3 display. We get the operation from the user, 1, 2, 3 or whatever, and because Python doesn't have a switch case, we have here 4 functions. The first one is the push operation. We display to the user, insert a number and get the number from the user or something else. If it is a number, we push on the stack the number. Okay, if it is not a number, we say to the user it's invalid input. Okay, the second operation, the pop, just gets the last element from the stack, and if the element is different from -1, it will show deleted data n. Okay, the third is the display, just invokes the stack.display, and the fourth operation is the exit operation, where we say that exit is equals to true and print exiting. Okay, we can put 3 dots here, and just that. The switch is just this, a dictionary where we put the number 1, number 2, number 3 as keys, and the values are the functions here. Okay, then we go to the switch and get from the switch the operation. Okay, we pass the operation, it gets the function, and then it executes. If nothing is found, it has this function, the exit operation. Okay, so let's run this. Stack implementation, choose an operation, push, pop or display. If we say display, it will say that the stack is empty. If we insert a number, 88, and then we display again, we have 88, and we want to pop the number, deleted data 88. Let's insert 3 elements, 1, 12, 1 again, 13 and 1 again, 14. Let's try to insert again, 15, and now it says that the stack is full. And if we display 3, we have 12, 13 and 14. Okay, this is the end, and as always, thank you for watching.